in 1967-68, one began to explore medical research uses of isotopes from the cyclotron. Now, the core concept is to administer radioactivity and be able to pick up where the radioactivity is in the body by virtue of the fact that that's emitting gamma rays, which are coming out of the body, and you can then detect them with a radiation detector. Now, eventually we'll talk about cameras and how we image that in 3 dimensions, but in that time, in the late 60s, mid to late 60s, all we had were individual detectors which just give you a signal. There's radioactive, like a Geiger counter equivalent. We didn't have a positron camera, so all we had was a nuclear medicine department equipped with these gamma cameras, but that was 700 feet away from the cyclotron unit. Now, and within the cyclotron unit then we didn't have imaging equipment. So I was very fortunate enough that my colleagues at Hammersmith are some of the world's experts in producing short-lived isotopes, and they wrote the definitive papers, John Clark, Peter Buckingham, and they said, okay, we'll pipe this from the cyclotron unit through the sewer to the medical physics nuclear medicine department. And we will have walkie-talkies and Heath Robinson ways of making sure they could deliver the radioactivity in a constant manner 700 feet away at a distance from the cyclotron. And that allowed us then in the UK to begin to image the brain's metabolism and blood flow. It was with a gamma camera, and it wasn't so good as the Boston camera, but nevertheless it gave us a chance to see what we will see in different diseases. And allowed us, through connections with Queen Square, which I can talk about later if you wish, but it allowed us to look at patients with tumours, with stroke, dementia, Parkinson's disease, lupus, qualitatively, but begin to make an impact. The clinical researchers saying, hello, this is interesting.